Hello, my name is Kiran Joni. This is the third in the introduction series of the Eso-Loop Framework. In the last session, I told you that I'm going to give an overview of the framework using the abstract of the paper. In this session, I will start with the first part of the abstract, that is the problem of entrepreneurial complexity. To start with, the key premise is that entrepreneurship is a complex decision domain. Scientifically speaking, there is no dispute on this point. The problem is that even though entrepreneurship is an extremely complex domain, as we already discussed, most of the prescriptive solutions in the domain of entrepreneurship are coming from extreme case of reductionism and narrowed disciplinary specialization. The key issue of concern in this session is to explore the nature of entrepreneurship, the true nature of entrepreneurship, before jumping into designing solutions. If we are designing for a particular domain, we need to understand the nature of that particular domain. We cannot simply exclusively rely on decontextualized epistemic specialization as a source for designing for a domain like entrepreneurship, which is extremely complex and dynamic. This is very similar to the idea of trying to understand the fundamental laws and dynamics of planetary physics before we try to send a rocket to the Mars or to the moon. So let us first of all try to explore the nature of complexity and the nature of entrepreneurial complexity, and through that exploration try to figure out the nature of entrepreneurship in its dynamics. Let us first of all start by understanding the idea of complexity. One of the earliest attempts to clarify the nature of complexity from a scientific perspective was coming from American mathematician Warren Weaver. In his work Science and Complexity, which was published in 1948, he tried to distinguish between three kinds of problems of interest to science. The first kind of problems are the problems of simplicity. These are problems with few variables. There are only few variables, and the relationship between these variables are studied using linear methods. These kinds of problems were solved very early on in the evolution of science. Second kind of problems are the problems of disorganized complexity. These are problems with massive number of variables, maybe millions, billions, and trillions of variables. But using statistical methods by measuring averages across variables, these kinds of problems were also solved by science very early on. The third kind of problems are the problems of organized complexity, and these are the problems which we are interested in. These are problems which involve dealing simultaneously with a sizable number of factors which are interrelated into an organic whole. Now, because of strong nonlinear interactions in this kind of systems, variables cannot be meaningfully averaged in this kind of systems, as in the case of disorganized complexity where statistics is applied successfully. According to Warren Weaver, organized complexity problems are too complicated to be solved with the 19th century techniques that was good at the few variable problems of simplicity. It cannot also be handled with statistical techniques that was effective in describing average behavior in problems of disorganized complexity. The key point to understand here is that even now, we don't have any tools or methods that can solve or even understand complex systems completely. This is an unfortunate situation, but this is the reality. Now, some of the key features of complex adaptive systems are the following. First of all, complex adaptive systems like entrepreneurship has non-linear dynamics. The dynamics of the system does not follow any kind of linear trajectory. It is non-linear dynamical system. Secondly, there are a large number of heterogeneous and interdependent components, elements, and variables. All of them have their own non-linear dynamics happening. Thirdly, self-organization is one of the key dynamical aspects of complex adaptive systems like entrepreneurship, where local interactions leads to global patterns emerging. This idea will be elaborated in the upcoming sessions because this is one of the core foundations of the framework. Another key feature is emergent property, in which the whole is not the sum of its parts. You cannot study the component part and try to figure out the nature of the whole. You cannot study human heart cell and try to figure out the functional property of human heart. Another key feature is non-proportionality, which is very much connected to the idea of emergent property. That means input doesn't equals to output. 1 plus 1 in this kind of systems is not equal to 2. Further, complex adaptive systems are open systems with fuzzy boundaries. There is no clear-cut boundaries to the system. Information and energy will come in and goes out. There is no boundary policing in these kind of systems, generally speaking. Further, complex adaptive systems have nested and embedded levels of complexity. That means complex systems are generally speaking embedded in other complex systems. Human heart is embedded in human body. Human body is embedded in ecosystem or biosphere. Finally, the dynamics of evolution is very much active in a complex adaptive system like entrepreneurship. Evolution, co-evolution, adaptation, exaptation, path dependency, all of them are very much important for a complex adaptive system also. Another key dimension to note is about the nature of causality in a complex adaptive system like entrepreneurship. In a complex adaptive system like entrepreneurship, we cannot know the causal structures a priori. Only after something happens, we can even try to understand the causal structures in a complex adaptive system. This is because we are dealing with a multi-causal system. There are multiple causes, there are emergent causes, there are cumulative emergent causes. There exists circular causation in which effects feeds back into becoming the cause. There exists non-proportionality, input doesn't equals to output in this kind of systems. Further, according to mathematician George Ellis, there exist multiple levels of hierarchy of structure and causation in this kind of systems. Sociological level and particle physics level are simultaneously in dynamics. Then there exists a temporal dimension. How long should we go back in history to try to figure out the causal nature? Is it even possible to do that? In fact, it is not possible. So our understanding of causal structures in a complex adaptive system is limited. We can only understand certain observable aspects. That is also extremely complex in nature. Now, because of this level of complexity, we cannot use traditional approaches to study a domain like entrepreneurship. Even approaches like regression analysis, which is one of the widely used methods for the study of entrepreneurship, according to scholars, is not really appropriate for the domain of entrepreneurship. This fact about regression analysis was highlighted in a recent publication by entrepreneurship scholars Elizabeth Berger and Andreas Kakets, which I thought deserved more attention from entrepreneurship scholars. Now, this level of complexity has real-world implications on human life and behaviors. I want to highlight two key dimensions of implications. First one is implication of complexity in human decision-making, and second one is on expertise development. In the paper, I have aggregated several key decision-making implications of complexity, which include uncertainty, boundary rationality, multi-causality, and many others. I'm not going to go through all these ideas because of time concern. But if you choose to do that, you can go and read it in the paper, which has attached citation that might help you explore further. The second key dimension is expertise development. The important thing to understand is that in a complex adaptive system like entrepreneurship, expertise is not possible because of the ill-structured nature of entrepreneurship. Entrepreneurship is a low validity domain when it comes to the possibility of expertise development. In a complex adaptive system like entrepreneurship, decision-making, intelligence, expertise, all of these are distributed in nature. Then there exist complexity laws like power laws, Matthew effects, reputation effects, preferential attachment. All of these are very much important. The dynamics of these forces makes it extremely difficult for us to connect a particular skill set to a particular outcome or a particular expertise to a particular outcome. It is not possible in actuality. Now, until now, we were looking at the nature of complexity and entrepreneurial complexity from an observer perspective. Now, let us have a look into the nature of complexity and entrepreneurial complexity from an actor perspective, from a doer perspective. So let us first of all have a look into the actor perspective, starting from an actor perspective to causality. As we already discussed, in a complex adaptive system like entrepreneurship, causal structures cannot be known a priori. Only after something happens, we can even try to understand the causal structures in a complex adaptive system. If somebody claims that they know the causal structures in a complex adaptive system, they are either misleading you or they don't know what they are talking about, or they are talking about a closed system and assuming it to be an open system. The key point to understand is that causal structures cannot be known a priori. But that doesn't mean that there is no causality in a complex adaptive system. Causality is fundamental. It is very much important. But the nature of causality in a complex adaptive system is dispositional. Or we can say we can only know the current dispositional propensity of the system. We cannot know the causal structures. Or better, we can say we can only know the current dispositional propensity of the system in relation to the disposition of the state space. Both these dimensions are very important. Let us have a look into some of the examples. We know that lions have a dispositional propensity to eat other animals, but it is not always 100% true. This means that it is not a causal structure that can be known a priori, but it is a dispositional propensity. That means lions can also be eaten by other animals. Sometimes it is also possible for a lion to get into an accident. For example, a lion could be attacked by a larger animal like an elephant and become paralyzed and then get eaten by smaller animals, or maybe ganged up by a group of hyenas. This happens all the time in nature. So even though there is a high propensity for lions to eat other animals, it is just a propensity, it is not a causal structure. It depends on the current dispositional propensity of the system in relation to the disposition of the state space. For example, if a lion is located in a normal forest, it gets to eat other animals. But if lion is put into a Jurassic Park where dinosaurs are the leading predators, then the story will change. Therefore, the key point is that the disposition of a particular system is important, but it is also relative to the disposition of the state space. Now, let us have a look into another example, an example of a sports game. What is the propensity that Ronaldo is going to score a goal in the next few seconds? Here also, we cannot know the causal structures a priori. We can only know the current dispositional propensity of the system. We know that Ronaldo is an extremely skilled player, so that adds to the current dispositional propensity. But the current dispositional propensity is in relation to the disposition of the state space. So the disposition of other players, the ball, the goalpost, the goalkeeper, all of them are equally important. Philosopher Alicia Herrero articulated this idea very well. According to her, the probability that a system will do X next depends on its present location in the current overall landscape, which in turn is a function both of its own past and of the environment in which it is embedded. So this articulates it beautifully. But can we apply this thinking to a domain like entrepreneurship? We looked into a biological system of lion where propensities are extremely high. We then looked into a structured complexity system that is a sports game. Now, can we apply this thinking to a domain like entrepreneurship? In fact, we can only know the current dispositional propensity in a complex adaptive system like entrepreneurship. We cannot know the causal structures here also. Take the example of a startup investor. The startup investor cannot know the causal structures a priori. He can only know the current dispositional propensity, which might include product-related propensities, like, for example, product market fit, scalability, network effects, legal and strategic advantage, person-related propensities that might include previous success, accumulated advantage, network of the person, social skills, leadership skills, character, ethics, etc. They might also look for environment-related propensities that might include entrepreneurship-friendly nature of the environment, whether there exists a growing industry and growing market. So all of these are part of the current dispositional propensity of a startup. Investor can make their judgment by understanding the current dispositional propensity only. They cannot know the causal structures. No matter how successful people are, they cannot know the causal structures a priori. They can only know the current dispositional propensities. In the case of successful people, they have an advantage. That is, they have other people working for them. So they have a distributed advantage of chasing dispositional propensities or tracking dispositional propensities. For example, there might be somebody working for Paul Graham who might be looking at the dispositional propensity of Chinese education market, Indian education market, or Indian artificial intelligence market. So they have this kind of accumulated advantage, and that's why once somebody becomes successful in this kind of a system, there exists accumulated advantage, Matthew effect. Preferential attachment is there. People want to connect with them. So they get massive advantage over others. It is not necessarily based on the kind of cognitive superiority or anything like that. They cannot know the causal structures anyway. So that's the point. We can only know the current dispositional propensity in a complex adaptive system. We cannot know the causal structures a priori. Now, this idea of dispositional causality or dispositional propensity has deep foundation in philosophy and science. We can trace this to Aristotle's concept of potentiality. Charles and his peers used the idea of propensities to indicate probabilities as propensities or would-bes. In modern philosophy, Karl Popper, who was known to be extremely reductive in his approach, embrace this idea of propensity after his encounter with quantum physics. Ecological theorist and philosopher Robert Ulanovich writes the following sentence about Popper's propensity. Quote, to Popper, the world is not closed. More precisely, it is not a deterministic clockwork, as Descartes would have us believe. Rather, it is composed of propensities, the tendencies that certain processes or events might occur. Generally speaking, in philosophy of science, dispositional realism is a branch or philosophical argument that holds the position of dispositional nature of causality. According to philosopher Stephen Mumford, who is a dispositional realist, terms such as causal powers, capacity, ability, propensity, and others can be used to convey the same idea. Further, many of the major approaches, concepts, and models I used here to build the Eso-Loop framework is also very much compatible with this idea of dispositional nature of causality and reality. Whether it is J.J. Gibson's idea of affordances, Stuart Kaufman's idea of adjacent possible, Dave Snowden's idea of dispositional mapping, Saraswati's idea of effectual behavior, Alicia Herrera's idea of constraints, all of these are extremely compatible with the idea of dispositional nature of causation. Generally speaking, the entire framework is built for aiding entrepreneurial decision making based on the current disposition or dispositional propensity of the system in relation to the disposition of the state space. To conclude, in this session, we looked into three important themes. First of all, we looked into the nature of complexity and entrepreneurial complexity. Then we looked into the implication of complexity by highlighting decision-making and expertise development implications. Then we concluded that we can only know the current dispositional propensity of the system. This means there is extreme case of context sensitivity. So with that idea in mind, our goal is thus to introduce various enabling constraints to increase the dispositional propensity of positive things happening and decrease the propensity of negative things happening in a complex system like entrepreneurship. So with that remark, I'm ending this session. See you soon in the next.